In our last example, we talked about the notation for representing example in a data set, which particularly will focus on points in multi-dimensional space, which denoted as a d-dimensional Euclidean space. So there, the capital X is a feature vector or point in d-dimensional space, which represented as a capital X is equal to x sub 1, x sub 2, ellipses until x sub d. So each component xa, where the a is ranging from 1 to d, is a real number, which represents a specific attribute of the example X. So in this specific context of clustering example we mentioned earlier in our last video, each capital city X is represented by two attributes, its latitude and its longitude. Thus, in this example, the x sub 1 represents the latitude and the x sub 2 represents the longitude. So this is a way of representing data points crucial in the data analysis techniques. Let's talk about the notation for d-dimensional Euclidean space. So first is for capital R, which represents the set of all real numbers. So it is a fundamental concept in the mathematics, and it is used to describe the quantity that have any value along a continuous scale, which including fractions, integers, and irrationals. Let's talk about superscript d, which indicates the number of dimensions in the space. For example, if we have two-dimensional Euclidean space, you may think it's like a flat plane, which each point is described by two coordinates like latitude and longitude or xy position. Or if we have three-dimensional Euclidean space, you may think it's like a 3D space, where each point is described by three coordinates like the latitude, longitude, and altitude or xyz positions. So we just plot a 3D scatter plot that visualize a set of data points which represent cars in three-dimensional Euclidean space, and each axis in this space represents a different attribute of the cars. So the first one is x-axis, which is the weight in kilograms. So this dimension represents the weight of each car. It varies from lighter cars, which is around 800 kilograms, to heavier ones, which is up to 1,600 kilograms. And the second one is y-axis, which is the engine power in horsepower. So this dimension showed engine power of the cars, which is measured in the horsepower HP. It ranges from the cars with less powerful engine, around 90 HP, to those with more powerful engine, which is up to 160 HP. And another axis is z-axis, which is fuel efficiency in miles per gallon. So this represents how fuel efficient the cars are. The values with ranging from 26 mpg to 42 mpg. Let's try to analyze this plot. So we have each yellow dot, which represents an individual car that characterized by its weight, engine power, and fuel efficiency. So the spatial distribution of these points gives us insight into how these three attributes vary among those different cars. For instance, the heavier car tends to have a more powerful engine but low fuel efficiency. So this visualization is very useful for identifying any trends and cluster in the multidimensional data. For example, if these points represent the car with high engine power and low fuel efficiency, which cluster together, it might suggest a trade-off between the power and the fuel economic. That could be interest of the manufacturers and consumers. So here we have a 3D representation of people in three-dimensional Euclidean space with each axis representing a specific attribute. So first is x-axis. So this represents the age of individuals in years. So the data point varies from young adults in the early 20s to individuals in the early 40s. And the next one is y-axis. So this axis displays the annual income of each individual in dollars. The range shows the span from 35,000 to 65,000, which illustrating a variety of economic standing. And another one is z-axis. So this dimension shows the numbers of years each person has spent in formal education, which ranging from 8 years to 17 years. And the yellow cross represents an individual person, which plotted according to their respective age, income, and education level. For example, the point at 30, 50,000, and 12 represents an 30 years old with an income of 50,000 and 12 years of education. And then we can get some potential conclusion and observation. The first is the possible correlation between the education and income. This plot suggests a potential correlation between a higher education and higher income. For example, the individual with more years of education, which towards the higher end on the z-axis, they tend to have a higher income, which is higher on the y-axis. So this observation, which is aligned with the general understanding of more education, can lead to better job opportunity and higher earning.